Okay, so this is lesson 2D, writing quadratic equations given 3 points. Problem 1. The table shows the height in h in feet of a wrench t seconds after it has been dropped from a building. Find the equation that models the situation, then use that equation to find the height of the wrench 5 seconds after it has been dropped. All right, so let's put it on a graph. Let's say that this is the height of the building. So the horizontal x-axis, let's change this x to t, because this is time. And let's use t for time. Actually, the variable t. The y is going to be the height. So let's have this be t. The height of the building is 400 feet. How do I know that the building is 400 feet tall? Is because at time equal to 0, that's where the wrench is at, 400 feet. So this, the tallest, let's put 400 up there, and break it down into half of 400 will be 200, 300, 100. This is a good breakdown of the height of the building. So let's go ahead and copy this down. So we're making this word problem into a math, and we're substituting in all the information into the graph here. So at time t equal to 0, how high off the ground is the wrench at time equal to 0? How high off the ground is it? Oh, you don't want to be on the recording. It is 400 feet, isn't it? At time equal to 0, this is time equal to 0, 400 feet. So here's where the wrench is at. At time equal 1 second, how high off the ground is the wrench? 384 feet? Yes? So at time equal to 1 second is 384 feet. So 1 is 384 feet is like right here, maybe somewhere right here. At time equal to 3 seconds, how high off the ground is the wrench? At time equal 3 seconds, how high off the ground is the wrench? 256 seconds. I'm answering my own question. So at time equal to 3, so you jump from 1 all the way to 3. So 3 seconds of giving you that information is about right here. So it's something like that. It's going like that. The graph of the height of the wrench with respect to time. It looks like a parabola. So what I'm going to do is that I'm going to assume that it follows a parabolic pattern, trajectory. So I'm going to use standard form of a quadratic to find this. Why am I going to use the standard form? Because I'm given 3 points. And when you're given 3 points, we can use standard form. What is standard form of a quadratic? And everybody was asking me on the quiz, what is standard form? Standard form is y equals a x squared plus bx plus c. That is called standard form of a quadratic. What I'm going to do is I'm going to substitute the y with the h for height. So height dependent on time is equal to, these are equivalent, y equals h of t. I'm going to leave the a alone. I don't know what that a is. X, I said I don't want to use this x. I'm going to change it to time, the variable t for time. So x, instead of x, I'm going to use t squared plus b. X is not x. I'm going to use t plus c. Now I'm going to substitute in the values given, and I'm going to use this one first. At time equal to 0, which I'm going to do, the height at t, I'm going to replace t with 0. The height at 0 is going to equal to, I don't know what a is. What do I plug in for t? What am I going to plug in for t? 0 squared plus b. T is 0 plus c is going to equal to, what is the height of the wrench at time equal to 0? 400 feet up in the air. Yes. Hopefully everything is making somewhat some sense right now. And now we're going to do some mathematics. What is 0 squared? And what's 0 times a? What is 0 times b? So 0 plus c is actually c, and c is 400. We have figured out what c is. What I need to figure out what is a, I need to figure out what is b, and I need to figure out c, but I already know what c right now is 400. So I need to figure out what a and b are now. I already got c. How do I figure out what c is? Or I'm sorry, how a and b are, what, because I already know c, is I'm going to use the next point given. So I'm going to say h of 1 is going to equal to, hopefully now you see the pattern here. We're going to plug it into the equation here. A, I don't know still what it is. What do I plug in for t? 1 square it. I don't know what b is. What do I plug in for t? 1. And don't I already know what c is? What is c? C is not 1. C is what? 400. And that is going to equal to, so what is the height at 1 second? How high off the ground is it at 1 second? 384. And now I'm going to do some mathematics here. What is what is 1 squared? 1. And what's 1 times a? A, thank you. What's b times 1? B. And what I'm going to do is I'm going to move that 400 over that way with the other number, minus 400. You guys all got calculators? What is 384 minus 400? So negative 16. Let's go, because I gotta get this going and be done with. So I got a plus b equal negative 16. I need another equation. So I got this equation, but I got two variables. I need to set up another one. How do I set up another one? I'm going to go ahead and use the last one given over there. Let's use this one. So I'm going to go, the height at 3 seconds is equal to A. What do I plug in for T? What do I plug in for T? Plus B times T. What do I plug in for T? And I already know what C is because C is 400. Has to equal to, what is the height at 3 seconds? What is the height at 3 seconds? It's 256. What is 3 squared? What is 3 squared? 9A. B times 3 is 3B. I'm going to minus 400 from both sides. You guys got calculators. What is 256 minus 400? Negative 144. I heard somebody say negative 144. And this is what I'm going to tell you, that mathematics builds on itself. I got that one, and I got this other one that I had previous. I'm going to stack them up on top of each other. A plus B is equal to, A plus B is equal to negative 16. Let's put it here. Oh, didn't we learn something like this in chapter 1, where I told you guys we can eliminate, we can either cancel out the A's or the B's? Let's say that I want to cancel out the A's. So what must I multiply the bottom by in order to cancel out the A's? Did somebody say negative 9? Good job. It is negative 9. Sarcasm is going to... So what's negative 9 times A? Negative 9A. What's negative 9 times B? Negative 9B. And what is a negative times a negative? That's going to be a positive. What's 9 times 16? Good, a calculator. You have one. 9 times 16. I think it's 144. Yes or no? What's 9A minus 9A? That is the whole point of this. Cancel out. And what is 3B take away 9B? Man, did I not put in so much? What's 3 take away 9? Is that negative 6? And what's going to be negative 144 and positive 144? Negative 144 plus 144, is that 0? Say yes. Yeah. Then how do I get the B by itself? Divide both sides by what? Negative 6? And so B is going to equal to what? What's 0 divided by negative 6? Put it in the calculator if you don't know what it is. It's 0. So I found B is equal to 0. I found B is equal to 0. Now I need to find A. How can I find A? Somebody say plug it in. That's good. Plug it in, yes or no? Plug it in here, yes, into this kind of equation. So it's going to be A plus what? B is 0, isn't it? A plus 0 is equal to negative 16. So another one. What's A plus 0? What is 5 plus 0? What is 5 plus 0? So what is A plus 0? So I found A equals negative 16. I have my A, B, and C. I'm going to erase this over here so I can finish the problem. So the equation that I needed was actually the height with respect to time is equal to, what is A? Thank you. T squared. What is B?
0.
What is C?
100.
Yes. This equation gives me the height at any time t. If somebody asks me a time equal to 2, a time equal to 10, this would give me the height. But it's asking me specifically for 5. So I'm going to do the height at 5 seconds. The height at 5 seconds, plug it in. Negative 16. T is 5 squared. I don't really need to put that down because it's going to be 5 times 0 is 0. Plus 400. 5 squared. What is 5 squared? What's 25 times negative 16? Negative 400. Negative 400 plus 400. What's negative 400 plus negative 400 plus 400? 0. 0. So at 5 seconds, how high off the ground is it at 5 seconds? Where is it? It's on the ground, because the height is what? 0 feet. And does this make sense? that it would be that. Let me see, let me see if we can, at time equal to 2 seconds might be over here. At time equal to 3 seconds, it was somewhere over here. At time, so it follows this curve like this. But if I do the curve down, oh, at time equal to 5 seconds, it's on the ground. It kind of follows the graph as well. That is it. So I don't know if we did it the same as the PowerPoint, but we finished it. And so at time equal to 5 seconds, it has hit the ground. It's 5 feet off the ground. All right, that's it.